Hello students. I am Ajay Sharma. Today I will tell you some basic concepts of electrical engineering. I will explain you some questions which are very helpful for entrance exam, or also I will tell their practical use also. So first question we have: in alternating voltage or alternating current, the peak value, this is called peak value, and it is also known as maximum value. The instantaneous mean at any time value of alternating voltage is given by the formula V0 sine omega t. This is V0. So this is the formula: sine omega. Omega is angular velocity and t is the time. So this is known as peak or maximum value. If this is V0, then this is minus V0. And in some question, you have to find out this peak to peak value. Peak to peak value can be determined V0 maximum minus minimum value. So it will be 2V0. So next question. We have three resistances connected in parallel. 1 ohm, 2 ohm, 3 ohm. Resistance, you know, resistance is the opposition to the flow of current. So their total value you can find by this formula also. 1 over R is equal to 1 over 1 plus 1 over 2 plus 1 over 3. 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So 6 is the LCM. 6 plus 3 plus 2, and it is 11 over 6. And when we will reverse it, so R will be 6 by 11 now. We can find this value directly. How? Just multiply these three resistance divided by multiply first two resistance plus multiply second two plus multiply third and first. So it will be 6 over 2 plus 6 plus 3. It is 6 over 11. So directly we can calculate in objective type question or in entrance exam. If we have 4 resistance, we will multiply the 4 resistance, and below first into second plus second into third plus third into fourth plus fourth into 1. So the same case is with the capacitor. Symbol of capacitor is like this: store the charge, or capacitor store electrical energy. Capacitor store electrical energy. So when three capacitors are connected in series, 1 microfarad, 2 microfarad, 3 microfarad, then their effective value will be same, 6 by 11 microfarad. Because when capacitors are connected in parallel, their total capacitance is calculated with the help of this formula. So similarly, if we have three resistances are connected in series, then their total value is R1 plus R2 plus R3. It is 6 ohm. And for this, capacitors are connected in parallel. 1, 2, 3. So This is simple formula, basic formulas for capacitor and resistance. So one must know it. If two resistances are connected in parallel, then directly we can find out total value 5 into 4 over 5 plus 4, 20 over 9 ohm. Similarly in the case of capacitor. So next question we have power factor. Power factor. It is the ratio of resistance over impedance. In impedance we will take also inductive reactance and capacitive reactance. So in impedance R, L and C. L have inductive reactance and C has capacitive reactance. And R over Z, R means purely resistance. So ratio of R over Z. This is also represented by cos phi. Phi is the phase angle between voltage and current. So power factor of a purely resistive circuit is 1. How it is 1, I will tell you. Also one thing you must remember, power factor of any material, anything lies between 0 and 1. Those electrical equipment instruments whose power or any transformer whose power factor lies very near to 1, that will be good. Their losses will be less. Okay, we will discuss it later. So in a purely resistive circuit, we have V and I are in phase. Voltage and current are in phase. When voltage and current are in phase, the phase angle phi is equal to 0. If in any circuit voltage and current are opposite phase, then phase angle is 180 degree. But here in this case phi is 0, so cos 0 is 1. So for a purely resistive circuit, the value of power factor is 1. Next question we have, in three phase we have three phases, red, yellow, blue. In three phase, this is neutral, where other terminal of three phase meet at a one point, that is called neutral. The angle between three voltages of three phase is 120 degree. Question is that the angle between three phase or EMF between the angle between the EMF of three phase is 120 degree. Remember it, very simple. Now, what is frequency? Frequency can be defined as number of cycles per second. So in place of cycle, oscillation can be written, oscillation, same thing. Vibration can be written, same thing. Waves can be written, same thing. So number of oscillation per second, number of vibration per second, number of wave per second is called frequency of the system, frequency of alternating cycle. So in AC the frequency is 50 Hz. What do you mean by 50 Hz? Mean in 1 second what happened? In 1 second there are 50 sinusoidal waves. 50 sinusoidal waves are there. So that is frequency of AC is 50 Hz. I will tell you later on when we will discuss hydraulic power station in nuclear power station. If we have this, so what is the frequency of this system? 2 Hz. Unit of frequency is Hertz. So 2 Hz. So frequency of AC wave, AC alternating current or voltage is 50 Hz. Used in India. This is used in India. You must remember it. And next is time period. can be defined as time taken to complete one wave, one oscillation, one vibration, and this time period is opposite of frequency. So 1 over hertz. So we can say that hertz minus 1. Or similarly, frequency is equal to 1 over time. We can say that second minus 1. Its unit is second minus 1. So basic concepts of electrical engineering, one must know it. Now we have next question. In purely inductive circuit, in purely inductive circuit, L, purely inductive circuit, LVI, voltage lead current by 90 degree. Voltage lead current by 90 degree. And so phase angle is 90 degree. So power factor cos 90 or cos 5 cos 90 is 0. Similarly, in purely capacitive circuit, CIV, current lead the voltage by 90 degree. Again this phase angle is 90 degree. So in purely capacitive circuit, power factor is 0. So you must remember it that if we have a circuit which is pure inductive or pure capacitive, their power factor is 0. Now, what is KVL? KVL, Kirchhoff voltage law. Kirchhoff voltage law, we have two laws, KVL and KCL. Kirchhoff voltage law, in any circuit, in any closed circuit, closed means this switch is closed. In any closed circuit, EMF applied is equal to sum of IR drops. So same current will flow through such the circuit, IR2 plus IR3. So we have to give a direction of current. So IR1, IR2, IR3 is equal to E. This we will, how we will put the sign? Here we have plus. And if we will give choose the current direction like this, so we have to write this E plus. In case we have this battery, then here we have negative, then here we will get the equation IR1 plus IR2 plus IR3. So by choosing the direction of current, we will see the last terminal of voltage source and put the equation. And KCL, Kirchhoff current law, it states that at any node or junction, so this is node or junction, NOD, node or junction. What is node and junction? Where a point where number of branches come or leave. So let I1, I2, I3, I4, I5, I6. This is I6. So in any node and junction, the sum of incoming currents is equal to sum of outgoing currents. So here I1 is coming here and I2 is coming here, I3 is going, I4 is going, I5 is going, I6 is coming. So sum of incoming currents is equal to sum of outgoing currents. This Kirchhoff voltage law and Kirchhoff current law, they are very important laws and helps to solve the electrical circuits. Then next question we have What is an ideal transformer? Ideal transformer. What is transformer? Transformer have two windings, primary and secondary. They are insulated with some insulator. These are laminations of mica. So transformer is used to step up or step down the voltage. Step up means if we here we have 6 volt, and if we will use a transformer or for step up, so input voltage is less, output voltage is more, and step down it is reverse. Here we have more voltage, here we have less voltage. But in ideal transformer is that transformer which had no leakage flux, no winding resistance, no copper losses, and no core losses. So zero, everything is zero. Leakage flux, winding resistance is zero. So it is 100% efficient. We say ideal means 100% efficient, but this is not possible. Some losses are there in every system. So, but we can write that ideal transform is that transformer which has no leakage flux, no winding resistance, no copper loss, and no core losses. The next question: big transformer placed in cooling or in oil to prevent its insulation and for cooling. So in some system we have very big transformer. They are kept in oil so that their insulation remains intact, and also they will cool the winding of the transformer when they get heated, when current passes through it. Now, what is permeability? Permeability can be defined as ability of a substance to absorb magnetic lines of force, or a substance in which magnetic lines of force can pass through. So different substances are having different permeability. So for ideal transformer, this permeability is given by the formula mu is equal to mu naught mu r. Mu is called absolute permeability, mu r is relative permeability, and mu naught is permeability of free space, and its value is 4 pi into 10 raised to power minus 7 Henry meter. You must remember it, very important. So for ideal transformer, this permeability where losses are zero is infinite. You must remember it, that permeability of an ideal transformer is infinite. Then in electrical circuit we have a word permittivity, just opposite to permeability for magnetic circuit, magnetic lines of force. So we write phi Weber, its unit is magnetic flux Weber. And permeability is the ability of a substance to absorb electric lines of force, or a material in which electric lines of force can pass easily has a good permittivity. And permittivity, formula for permittivity is This is known as absolute permittivity of free space, and its value is 8.854 into 10 to the power minus 12 farad per meter, and this is relative permittivity. So this is the related to in electrical circuits. So what is resistance? Resistance word is used in electrical circuit where current flows. Resistance is the opposition to the flow of current. Opposition to flow of current. So resistance opposes the current. Let we have a circuit. I will explain you. 10 ohm, and this is a DC source is there, 10 volt. The current V is equal to IR, Ohm's law. We know that Ohm's law, V is equal to IR. So I will be equal to V divided by R. So it is 1 ohm. So 1 ohm. Let this resistance is increased by 10 from 10 ohm to 30 ohm, and voltage source is same. Then current will be I is equal to 10 over 30. So 1 over 3.33 ampere. So as resistance increases, current decreases. So resistance is the opposition to the flow of current. Next we have reluctance. Reluctance is the word used in magnetic circuit. So reluctance opposition to the flow of magnetic flux in a magnetic circuit. This reluctance can be given by formula A is equal to mu over mu naught R. This is also equal to MMF over phi. MMF, magnetomotive force in electric circuit, and we have EMF, electromotive force in MMF is in magnetic circuit, EMF is in electric circuit. So MMF, unit of MMF is ampere turn, current into number of turn, phi Weber. So it is ampere turn per Weber. So resistance and reluctance. So then we have reluctivity. Next we have reluctivity or specific resistance. Reluctivity or specific reluctance. So reluctivity or specific resistance, opposition to the flow of magnetic flux in a magnetic circuit. But for this we have to consider length of the conductor 1 and area of cross section is also 1. Though S will come as 1 over mu naught mu bar or 1 over mu. Similarly, reluctivity or specific reluctance. Okay. Similarly, we have resistivity or specific resistance in electrical circuit, and here R is equal to rho L over A. This rho is resistivity or specific. In this case also L is taken as 1 and A is 1, so R is equal to rho. So these are some basic questions of electrical engineering. I want to tell you that I am an electronics engineer. I am graduate in electronics and telecommunication engineering, and I have 35-year experience of CNC machine. So I can explain about CNC machine, PLC machine, part program, microprocessor. Then I can also explain the subjects physics and mathematics from class 8th to class 12th, along with entrance exam of JEE, electrical and electronics of Railway Electricity Board. Plus, I can also give coaching of all electrical and electronic subjects of diploma and degree students. If anybody wants this coaching on any subjects, then he can contact me 977952208, or my email ID is vijaySharma1873@gmail.com. Okay, thank you students.